Hello guys, it's Natalie Vargas. Why did the two stubborn vectors get lost? I'll let you have a minute to think about it. It's because the vectors wouldn't stop to get directions. So if you didn't understand this riddle, hopefully you will by the end of this video, because today we'll be reviewing vectors. Vectors are defined as a quantity that has both magnitude and direction. Magnitude is the length of the vector, or you could also think about it as the distance from the tail to the head of the vector. And direction is the direction that the vector is pointing. Vectors are represented with arrows. Vectors can be written in either unit vector form or column form. An undercase bold letter is used to represent a vector, but with handwriting it's difficult to tell when it's bold, so oftentimes we underline the lowercase letter to represent the vector. In this example, vector A equals 6i minus 7j plus 2k is the same thing as vector A equals 6, negative 7, 2. The 6 is horizontal, the negative 7 is vertical, and because these are 3D, I like to think about the 2 as sort of coming out. In column form, the components are not referred to as the I, j, or k values, but rather x, y, and z. However, they essentially all mean the same thing. There are also vector equations, which are made up of a position vector, a directional vector, and a scalar, which is our constant. Vector equations of lines are similar to the standard y equals mx plus b. For example, in y equals 2x plus 5, if you plug in a 1 for x, you get 7 for y. If you plug in a 2 for x, you get 9 for y. And if you plug in a 3 for x, you'll get 11 for y. Vector equations work very similar. Let's get started with our first example. Line L1 is represented by this equation, and line L2 is represented by this equation. L1 and L2 intersect at point A. Find the coordinates of A. The first step here would be to set our components equal to each other. So, 4 plus 2s is equal to 6 minus 2p. Now, moving on to the y. 10 plus 4s is equal to negative 6 plus 6p. Then, moving on to the z. 6 plus 6s equals 16 minus 8p. Now, we just have to solve a system of equations. First, we'll isolate our s value. 4 plus 2s equals 6 minus 2p. First, we'll subtract 4. 2s equals 2 minus 2p. And then all we have to do is divide by 2. And s equals 2 minus 2p over 2. However, this can be further simplified by dividing both values by 2, and we'll end up with s equals 1 minus p. Now that we know our s, we can substitute it into this s in order to find p. So 10 plus 4, and then we'll put this over here. 1 minus p equals negative 6 plus 6p. Now we'll distribute the 4, and we'll end up with 10 plus 4 minus 4p still equals negative 6 plus 6p. Then we add like terms. 14 minus 4p equals negative 6 plus 6p. Then we'll subtract the 14 from both sides, of course, and we'll end up with negative 4p equals 20 plus 6p. Then we'll add or subtract the 6p from both sides again, and we'll end up with negative 10p equals negative 20. This is a negative 20. Then we'll finally divide by negative 10 in order to isolate our p, and we'll find that p equals 2. So far we found that p equals 2 and s equals 1 minus p. In order to find our s value, we can substitute the p value here. So if we do that, we'll get s equals 1 minus 1 times 2. S equals 1. 1 times 2 is 2. 1 minus 2. And then we'll find that s equals negative 1. Now we know both our p value and our s value, so we can substitute into our equations to find the coordinates. So 4 plus 2 times negative 1 is equal to 2. 10 plus 4 times negative 1 is equal to 6. And 6 plus 6 times negative 1 is equal to 0. We can also substitute our p value to see if we get the same coordinates. 6 minus 2 times 2 is equal to 2. Negative 6 plus 6 times 2 is equal to 6. And 16 minus 8 times 2 is equal to 0. As you can see, both the coordinates we found are the same. Therefore, point T has coordinates 2, 6, 0. This is where line 1 and line L2 intersect, and this is your final answer. Moving on to the next problem. Let vector PQ equal 5, negative 3, 3, and vector PR equal negative 3, negative 4, 1. Letter A asks us to find vector QP, and letter B asks us to show that PQ is perpendicular to PR. Let's begin with letter A. Letter A asks us to find QR. So we're trying to get from Q to R. In order to find QR, we subtract vector PR vector PR minus vector PQ. So we take the components of PR, which are negative 3, negative 4, and 1, minus the components of PQ, which are 5, negative 3, and 3. And we just subtract straight across. So negative 3 minus 5 is equal to negative 8. Negative 4 minus negative 3 becomes negative 4 plus 3, which is equal to negative 1. And 1 minus 3 is equal to negative 2. So these are the components of vector QR. Vector QR is equal to negative 8, negative 1, negative 2. Moving on to letter B. Show that vector PQ is perpendicular to PR. We know that perpendicular vectors have a scalar product which is equal to 0 and intersect at 90 degrees. In order to find the scalar product, we multiply vector PQ times vector PR, and it should be equal to 0 since these are perpendicular vectors. So we take 5 times, and we follow the formula in our IB data booklet, which says that V times W equals V1 times W2 plus V2 times W2 plus V3 times W3. So in terms of our vectors, this means 5 times negative 3 plus negative 3 times negative 4 plus 3 times 1. Then we multiply negative 15 plus 12 plus 3. And we find that it is equal to 0. So this is an indication that the vectors are perpendicular. Next, we can show that the angle between the two vectors are equal to 90 degrees by following the equation in our IB data booklet, which says that cosine of theta is equal to the dot product over the magnitude of V times the magnitude of W. And the magnitude of v is given by the square root of v1 squared plus v2 squared plus v3 squared. So let's begin with vector pq. Finding the vector of pq, the magnitude of vector pq. So we do this by taking its components and squaring them. So 5 squared plus negative 3 squared plus 3 squared. And this ends up being equal to the square root of 25 plus 9 plus 9, which is equal to the square root of 49. In order to find the magnitude of vector PR, we do the same. So the square root of negative 3 squared plus negative 4 squared plus 1 squared. We find that this is equal to 9 plus 16 plus 1, which is equal to the square root of 26. Now that we have found all of the components of the equation, we can simply plug them into the equation. So cosine of theta is equal to 0 over the square root of 26 times the square root of 49. And you want to make sure that your calculator is in degree form, and take the inverse of 0 over the square root of 26 times the square root of 49, and we'll find that theta is equal to 90 degrees. So that's how you can show that vector PQ is perpendicular to vector PR. Now let's move on to the IB exam style questions that you should be able to do on your own. L1 is represented by R1 equals position vector 10, 6, negative 1 plus direction vector 2, negative 5, negative 2 times S. And L2 by R2 equals position vector 2, 1, negative 3 plus direction vector 3, 5, 2 times P. L1 and L2 intersect at point B. Find the coordinates of point B. Take a moment to solve this problem, which is worth around 7 marks. And this should be your final answer. Point B has coordinates 8, 11, 1. The final IB exam style question is, the following diagram shows the triangle ABC such that vector AB equals negative 6, 0, 8, and vector AC equals negative 2, negative 6. Question A asks to find vector BA. Question B asks to find vector BC. And question C asks to find the cosine of ABC or angle B. And here is the diagram. I'll give you a couple minutes to solve this. And these are the answers. Vector BA equals 6, 0, 8. Vector BC equals 4, 2, 2. And finally, the cosine of ABC is equal to 40 over the square root of 24 times 10. Hope you enjoyed.